Hi everyone, I hope you are well and that day is going well. Today we will be covering some physical concepts with you. We will talk about inverters, dipoles and accelerator cavities. We hope that this video will be enriching for you. Without further ado, we begin. Inverter.
Also known as UPS or ISI, UPS are very useful tools for today's business structures. This device works like a microgenerator, allowing you to obtain the necessary electricity to back up your office data and shut down your applications in case of sudden power cuts. Its main function can be summarized. It can be used as a backup power supply in case of power failure. As soon as the UPS detects a sudden power cut, its batteries automatically take over and power the computer for a period corresponding to the autonomy. The autonomy is variable and depends on the consumption of the device connected to it. Like a true backup generator, the security gives the user time to save open documents and exit the software they are working on without losing data. It can be used as a clean source of electricity. An inverter is not only intended to compensate for power cuts, its role is also to stabilize the electricity voltage and to eliminate electrical interference. The UPS is an important link in the security of computer systems. Its main task is to take over from the mains when power cuts occur, giving users time to save the work in progress. Outages are not the only incident that this device has to deal with. Filtering as well as voltage regulation are also important functions. A good inverter should ensure a continuous supply of electricity to the device, but also ensure that the power is of good quality. An inverter consists of three parts: the rectifier, which transforms the alternating current into direct current to charge the batteries and power the inverter, the batteries that store the energy, and the inverter, which transforms the DC voltage delivered by the rectifier or the batteries into an AC voltage of 250 volts at 50 Hz, identical to that of the mains. Therefore, the inverter is a very useful and ever indispensable tool for professionals.
Dipoles. In electromagnetism, there are two kinds of dipoles: an electric dipole or a magnetic dipole. An electric dipole deals with the separation of the positive and negative charges found in any electromagnetic system. A simple example of this system is a pair of electric charges of equal magnitude but opposite sign, separated by some typically small distance. And a magnetic dipole is a closed circulation of an electric current system. A bar magnet is an example of a magnet with a permanent magnetic dipole moment. Dipoles, whether electric or magnetic, can be characterized by their dipole moment, a vector quantity. For the simple electric dipole, the electric dipole moments point from the negative charge towards the positive charge, and has a magnitude equal to the strength of its charge charge times the separation between the charges. For the magnetic current loop, the magnetic dipole moment point through the loop with a magnitude equal to the current in the loop times the area of the loop. Similar to magnetic current loops, the electron particle and some other fundamental particles have a magnetic dipole moment. As an electron generates magnetic field identical to that generated by a very small current loop, however, an electron's magnetic dipole moment is not due to a current loop, but to an intrinsic property of the electron. The electron may also have an electric dipole moment, such as yet to be observed. A permanent magnet, such as a bar magnet, owes its magnetism to the intrinsic magnetic dipole moment of the electron. The two ends of a bar magnet are referred to as poles and may be labeled north and south. In terms of the Earth's magnetic fields, they are respectively north-seeking and south-seeking. If the magnet were freely suspended in the Earth's magnetic field, the north-seeking pole will point towards the north, and the south-seeking pole would point towards the south. The dipole moment of the bar magnet points from its magnetic south to its magnetic north pole. In a magnetic compass, the north pole of a bar magnet points north. However, that means that Earth's geomagnetic north pole is the south pole of its dipole moment and vice versa. The only known mechanism for the creation of magnetic dipole are by current loop or quantum mechanical spin, since the existence of magnetic monopoles has never been experimentally demonstrated.
Accelerator cavities. A accelerator cavities is a machine that uses electromagnetic fields to propel charged particles at very high speed and energies and to contain them in well-defined beams. Large accelerators are used for fundamental research in particle physics. Among other things, it allows to study a particle motion, collision phenomena, and allow study to be carried out to find new particles. For further information, the largest accelerator currently operating is the LHC Large Hadron Collider near Geneva, Switzerland. We have several models and different modes of operation, but the objective and general idea remain the same. For example, they present you the cyclotron and its mode of operation. Thanks for watching the video. We think we have enriched your knowledge. Goodbye.